Let me tell you why I like being a consultant for IOHK, why I find them so exciting. If you look at a firm like Google or Facebook and they do something interesting like MapReduce, when they're done with it, they will publish it. What they don't do is what IOHK does, which is to say, hey, before we use this rather tricky cryptography, let's get it peer-reviewed. Right? I'm an academic. Academics have a superpower that many people don't know about. It is called peer review. You publish something, before you publish it, you get experts to read it and say, yeah, this looks okay to us, and then you publish it and the community reviews it and tells you if you've got it wrong. Sad to say, sometimes as academics, we get it wrong. So it's really important to have it reviewed by the community. So all the cryptography work that's been done by Aggelos and his team has been published. There's the first paper, there's the other one. They've all been published in advance of turning them into products. And all the work we're doing, including Plutus, our key goal is to get it published. So Plutus hasn't been published yet in that form, but it was published a while ago, as I will tell you. Now, the other reason I'm excited to work for IOHK is because they've made a commitment to using Haskell. I and many other people, some of them in this room, were involved in the design of Haskell. It's been growing for 30 years. Here's the secret, by the way, to doing something great. Do it, keep at it for 30 years. Your students will graduate, and they will start using it to do great things. Right? So all you guys here, you're planning to succeed next year. Don't worry about it when you don't succeed next year. Just keep at it for 30, and you will be fine. So let me tell you a little bit about Plutus platform. And the main thing I want to tell you about Plutus platform is it has a really great idea in it. And it's not my really great idea. It's Manuel's really great idea. And here's the thing. When Manuel came to us, he said, oh, yeah, let's look at, say, the way you do a crowdfunder on a smart contract platform like Ethereum. So he found one that was published. And here it is. It's 81 lines of solidity. That's the language everybody thinks you program Ethereum in. But the published thing isn't just 81 lines of solidity. It's also 149 lines of JavaScript. So what Manuel noticed is that, well, wait a minute, we don't just have one program. You've got the on-chain program, that's written in Solidity, and then you've got the off-chain program, which in this case is written in JavaScript, and they must work together. You have to have something off-chain to drive the thing that's on-chain. So everybody has this problem, but only Manuel noticed it. And we've seen this problem before. So I've worked on a web language called Lynx, which is about the idea that you've got one thing running on the server on the web and another thing running on the client, and they need to talk to each other. So server is just like on-chain, client is just like off-chain. So we've seen this problem before, and we actually know a solution, which we then adopted. So in Plutus platform, it's all written in Haskell, both the bits that run on the chain and the bits that run off the chain. And everything green here runs off the chain. And then we've got these funny little brackets, which you'll learn more about, which let you write Haskell inside of them. And so this is just it's a Haskell, but it's a subset of Haskell. Not everything will run on the blockchain. And you write everything in Haskell, including both the off-chain and on-chain bits. So he'll tell you more about that, and you will also learn about Plutus Playground, which lets you try it out yourself on the web. So we've got 3 different ways of doing this: Plutus Playground, an emulator, and of course Cardano. And they all run the same, but you have to run on Cardano if you actually want to spend ADA. Now, what actually runs on the blockchain is not Haskell, because Haskell's this huge language. It has no formal spec, and it's changing all the time. And what's key when you deploy something to the blockchain is you want to avoid a hard fork, right? You want to do something that will stay there for a while. So how do you design something that's going to be around for a while? Well, here's an idea. Use a programming language that's 80 years old. It's been around since before the first stored program computers. And that's the lambda calculus, invented by, or discovered perhaps, by Alonzo Church in 1932. We used the simply typed lambda calculus, which was written down in 1940. And it's not just something that one person found, right? The reason I use discovered rather than invented is because in 1935, Gerhard Gentzen wrote down the formulation of symbolic logic we use to this day, and that's called natural deduction. And in 1969, William Howard published, oh, actually, these two are the same thing. They're exactly identical. The types correspond to propositions in the logic, the programs correspond to proofs in the logic, and evaluating the proofs corresponds to evaluating the programs corresponds to simplifying proofs in the logic. So this is a principle called, shameless plug here, propositions as types. And if you want to know more about it, you can read about it in Communications of the ACM. That was published in December 2015. But the idea goes back quite a ways. Some people attribute it to the intuitionists in the 1930s. Some people attribute it to Howard. Some people attribute it to De Bruyn. So rather than giving any one person's name, I refer to as propositions as types. So that's a great idea. Let's use something 80 years old. Well, actually, we use a variant of it. The variant's only 40 years old. That's called the polymorphic lambda calculus. It was discovered by the computer scientist John Reynolds in 1974. But in fact, it was also discovered 2 years earlier by the logician Jean-Yves Girard. And that's the basis for the type systems that you find in Haskell and every other typed functional programming language. So that allows you to define something like a sort function and to use it both to sort lists of integers, lists of strings, lists of what have you. So polymorphism is a very important idea. And that's it. That's really all the ingredients that we have. And we've done that to make it future-proof. And because you want some kind of module system, turns out module systems are still something that people are trying to work out. But the System F gives you a module system that's quite solid. So as long as you don't add other junk on top of it, it works really well. So we've just not added other junk on top of it. So we've got a 40-year-old programming language and have some hopes that that will last for more than a year on the blockchain. And there it is. That's the semantics written out for you. I think you've all been given napkins that have this on them. So that's it. That's all I want to tell you. What I want to leave you with is the idea that if you've got a tough job to do, you should think that this is a job for Plutus.